So let's start lecture 14. In this lecture, we are going to cover speed time graph and velocity time graph. Same will keep video length of roughly half an hour. And remember, speed time graph is speed versus time graph. Both are scalar quantities. So first thing you should keep in mind, your graph will never go to the negative direction. Your graph will never return back. Okay. But in velocity time graph, velocity is vector quantity, so it is possible. Graph can go back, graph can go negative. Let's understand what my meaning is. So first I will explain speed time graph, or it's better to understand speed time graph and velocity time graph one by one. So I'm taking VT here. Then first point you should make sure, if you have speed time graph, here your V is representing speed, but same V will represent velocity when I'll be teaching velocity time graph. So, and one more thing you remember, if you have straight line motion, then speed and velocity numerically they will be same, magnitude wise they will be same, because direction is constant in a straight line. Okay, but that does not mean velocity and speed they have the same meaning. No, they don't have the same meaning. Velocity contains direction, always there is a difference. Okay, so first thing you keep in mind, if I will find out slope of VT graph, then this is going to be acceleration. Second thing, if I will find out area of VT graph, then this is going to be your distance. Okay, distance or displacement also. When can you say displacement? If your V is representing velocity, then it will be displacement. But if your V is representing speed, then it is going to be your distance. Totally clear? Okay. So speed time graph. Let's start with our same. If you have this kind of a straight line, so this kind of straight line will represent something. What is that? Let's understand. So what you have to check? First thing, motion is there or not. This is the first thing you have to cross check. So you can see your time is increasing in this direction, but at this time you have some speed. At this time you have some speed, but both speeds are same. At this point again all the speeds are same, so you have a particular speed here. Suppose I'm giving some numbering here, and this speed is coming 10 meter per second. It means what? At different time, when time is increasing, your speed is not increasing, it is always 10 meter per second. What does it mean? Meaning is very clear, your speed is not changing. Okay, now see, there are two ways to discuss speed is not changing. Because its speed is not changing, so your acceleration is zero directly because of theory. Because if speed is not changing and it is a straight line, so direction is also not changing, right? So acceleration is zero. Because if speed is also not changing, direction is also not changing, then velocity will not change. Correct? Because velocity is the combination of speed and direction. If both are not changing, how will you know direction is not changing? Direction sense we don't have in the graph. No. In the graph we only bother about the magnitude. So anyway, direction and speed they both are not changing. That's why your acceleration is not changing. Is not there. So your acceleration is zero. This is one thing. Next thing, with the help of slope also you can check acceleration is there or not. So for that what will you do? Very simple approach. I'll change the color. I'm taking which color? This color. Okay. At this point, if you draw slope, it will be this kind of line. So this line is parallel to x-axis, so it does not make any angle. So angle made by this line with x-axis theta is equal to 0. So tan theta is equal to 0. So you got your slope 0. So your slope is coming 0. And just now I have told you slope of VT graph is acceleration. So your acceleration is 0. So there are two ways to check acceleration is 0 or not. One thing, with the help of this concept, that is speed and direction they both are not changing, that's why your speed is 0. Next thing, with help of slope also you can check. And next thing you check, your slope is changing or not? No, slope is not changing. At every point you have same line, same line, same line. So theta is 0 for every point slope. Okay, this part is clear. So only one thing, what are the outcomes are there from this graph? So first thing, slope is not changing. Okay, first thing, motion is there or not? Yes, motion is there. What kind of motion is that? That is the second question. What kind of motion is there? Uniform or non-uniform? So it is uniform motion. So third point, acceleration is 0. These are the things you can get. Now suppose one thing is clear, motion is there. So in ST graph, when I was teaching you displacement and distance time graph, that time only this much we used to calculate. Okay, when I was teaching you ST graph, then we used to find out velocity with the help of ST graph with the slope method. But now I am teaching you VT graph. So from VT graph you will be judging two things. First thing, acceleration, and next thing, you can also judge what is the distance traveled. Okay, always remember, if I have this kind of line and this is your speed time graph, then I can ask you, suppose these are the points I am marking for time parameter. So suppose here I have t is equal to 1 second, 2 second, 3 second, 4, 5, 6, 7. Suppose I'm asking from t is equal to 3 second to t is equal to 7 second, how much distance was traveled? This distance, this speed is actually, suppose 10 meter per second. Okay, so you can see it is a uniform motion. So I can ask you two things. First thing, with the graph you tell me what is the acceleration. Next thing, what is the distance traveled between time t is equal to 3 second to time t is equal to 7 second. Two questions I can ask. So acceleration part is totally clear, it is 0. Why? Because it is uniform motion. But how will you find out distance? So in that case, remember, area of velocity time graph gives you distance. So how much area is being covered between this 3 second to 7 second? So here 1, 2, 3, 4 unit length is here, but actually it is 4 second. And on the vertical axis, how much length is there? So this total length is already 10 second. So this is 10 unit. It means this is 10 second actually. Okay. So if you want to find out this area, means which area? Area means this area inside this. Which area? I hope it's clear. This total area I am talking. This total area. This area we have to cover. So if this much area you want to find out, you remember this is a rectangle. How do we calculate? So if this part I will take outside, actually this part I can take outside. Take this part outside. If you are taking this part outside, then you know what is the length and breadth of the rectangle. So this was 4 second and this was 10, right, meter per second. Understand one thing, if you multiply length and breadth, it means what? 10 meter per second you multiply with 4 second. So what will happen? Second will get cancelled. So 10 meter into 4, that is I'm sorry I'm sorry. So 40 meter. You can see we are remaining with meter. That's why when we calculate area of a VT graph, we get meter. So that is 40. What is this 40? 40 is that distance which is traveled from 3 to 7. Okay. And one more thing you can say, because this speed is uniform, so in every equal time you'll be getting equal answer of distance. Correct. Now we'll go for different type of displacement time graph. Distance time graph. Distance time graph. So this graph is, remember, you cannot have this kind of graph. Oh, very sorry, we are discussing speed time graph. I'm sorry. Actually जुखाम के चक्कर में ना सब कुछ भी निकल रहा है मुंह से. We are discussing speed time graph. कल रात से ही थोड़ी सी तबीयत डाउन है, लेकिन फिर भी वीडियो तो बनाना है. फ्री रह के क्या बैठे हैं, बैठे बैठे क्या करेंगे, काढ़ा पी पी करके पक गए, और जल्दी हम इंग्लिश मेडिसिन के लिए जाते नहीं हैं। चलो चेंज करते हैं कलर, इसको लेते हैं। तो इसमें सॉरी गाइज, वन मोमेंट। कल aerospace, in last class I was taking last night aerospace class, that class was also kind of disturbed. I take night time 8:30 to 11 for aerospace department. Okay, now see guys, this is our speed time graph. So I was saying these kind of graphs are not possible because speed is a scalar quantity. Scalar quantity, now understand? Do you think if I compare this graph with distance time graph, so if you do like this kind of graph says when time is increasing, you can see at this time you had this distance, at this time you had this distance, at this time you had this distance. So you may be thinking that I told you that distance cannot decrease because it is a scalar quantity. So same concept you may think here. At this time you have this speed, at this time you have this speed, at this time you have this speed. So there is a trap. You guys are in trap now. Now what to do? You are in trap. You may be thinking that this is also a scalar quantity, this is also a scalar quantity. That's why in the beginning itself I said something just to put you in trap. Okay, so sorry guys, really it is so much trouble today. One moment guys, fully disturbed, day is going worse today, nose flow. Okay, so see, you guys may be thinking that even this graph is not possible, but actually this graph is possible. Distance cannot decrease, but speed can decrease, right? When you slow down your bike, suppose you are running bike or cycle or bus or truck, anything, you apply brakes, then speed slow down, right? So speed can slow or not? Speed can slow down, no doubt in this. Distance cannot decrease, but speed can decrease. So this graph is possible. So in the beginning when I said that it cannot decrease, it cannot turn back, this was to give you some extra pressure so that when in the last I will explain this part, easily you can get the right logic. Distance cannot decrease, but speed can decrease, then only vehicle will come to the rest. Remember, if speed will not decrease, then you can never stop, you can never go back to your home. Speed can decrease and then only body will come to the rest. So what is happening here? So either speed or velocity, both can decrease, right? So this graph is possible. So here your speed is decreasing. So one thing, at this time what was your speed? This much. At this time what was your speed? This much. At this time what was your speed? This much. Speed is decreasing. So there will be another time, like this time speed becomes 0, body came to the rest. So in this entire journey speed is decreasing. So what will you say? Retardation is there, not acceleration, retardation, or you can say negative acceleration is there. So your first thing, motion is there or not? Yes, motion is there. Second thing, it is uniform or non-uniform? So it is non-uniform. What kind of non-uniform? Acceleration or retardation? So retardation. Okay, so I can ask the value of retardation. So it should be negative acceleration, right? So how much acceleration? How will you find out? So to find out that, you will find out at this point what is the slope, at this point what is the slope, at this point what is the slope. So point is, at every point you are getting same slope. It means acceleration is there, that is clear. At this point also you have acceleration, at this point also you have acceleration, at this point also you have acceleration. Acceleration is there, but that acceleration is not changing. Velocity, speed is changing, but acceleration is not changing. How will you calculate that acceleration? to calculate that acceleration you should find out slope. How can you calculate slope? Very very easy. How? You just find out this angle theta and put into tan theta, so it will give you negative answer. That will be your negative answer. Why tan theta will come negative? Remember, if theta is more than 90, then tan theta will give you negative answer. All these small points you should note down in your notebook. Okay, so whatever is tan theta, so suppose theta is anything, like just in this case suppose theta is 120, so it is going to be tan 120. Automatically this answer will come negative. Why? Because 120 is more than 90. Now many students may not be thinking, may not be remembering what is the value of 120. So if you remember, then very good. If you don't remember, just find out how to solve this. Sorry, आज बहुत दिक्कत हो रही है, आज और काढ़ा पीना होगा. एक्चुअली क्या है, मेडिसिन लेने से जल्दी हम प्रेफर नहीं करते अंग्रेजी दवा. ये काढ़ा वाला पीते रहते हैं, अदरक उबाल के पियो, लौंग पियो, यही सब ठीक होता है. बॉडी को अंग्रेजी दवा थोड़ी नुकसान भी करती है, ज़्यादा खाओ तो. हम तो खाते ही नहीं हैं, जब तक बहुत ज़्यादा सीरियस ना नहीं खाते. ओके, सो अब ये tan 120, नाउ वी हैव टू कैलकुलेट tan 120 वैल्यू. So you can calculate as 90 plus 30, or you can calculate using 180 minus 60. Two ways are there. You can easily get the answer. Comment me what will the answer. So this answer will come negative, don't worry. This will come negative. So why negative is coming? Because it is retardation. That's why answer is coming negative automatically. So this is one thing. Now next thing I can ask, I can also ask you, suppose this is t is equal to 3 seconds and this is t is equal to 6 seconds. So how much distance you have traveled from t is equal to 3 seconds to t is equal to 6 seconds. So in that case I should give you this maximum height also. So suppose this maximum height is 5 meter per second. I will draw this curve again. Okay, here I am saying this is time t is equal to 3 seconds, and here, sorry, this curve is not this curve. Actually this curve should touch the horizontal line properly like this. So at this point you have t is equal to 3, at this point you have t is equal to 6 seconds. So at this point I am saying your velocity speed is v is equal to 5 meter per second. So now I am telling you how will you find out the distance distance traveled from t is equal to 3 to 6. Very easy. You can calculate the area, right? So how will you calculate the area? So this time it is not rectangle, this time it is triangle. So half into base into height will be the area of the triangle. So base is 3 to 6 is nothing but 3 unit. This distance is 3 unit. So half into 3 seconds into what is the height? Height is 5 meter per second. 5 meter per second. So second will get cancelled. So 5 meter and 3 by 2. So 15 by 2 meter. So this is nothing but 7.5 meter. This much distance vehicle will travel in this time. Okay, and acceleration will be how much? It depends what is this value. Okay, you can also calculate your acceleration using the concept of slope. Okay, so at this point what is the coordinate? Let's find out. So suppose this is v1 t1. At this point what is the coordinate? So suppose this is v2 t2. Okay, so you can see, actually I should not write like this. I should write t1 v1 and here t2 v2. Actually our convention is we should write x coordinate first and then y coordinate. So t1 is 3, v1 is 5 here. Okay, and here t1 is 6, v1 is 0. So to find out acceleration, sorry, retardation, you write here v2 minus v1 by t2 minus t1. This concept we have already seen in previous classes. So here v2 is 0, v1 is 5, because you can see v2 is 0 and v1 is 5. t2 is 6, this is 3. So we are getting minus 5 by plus 3. So it is coming minus 5 by 3. So this will be your retardation. So this is one way to calculate using this concept. Another way is, if this angle is known, then also you can calculate using tan theta. That will also give you same answer. Okay, now some more we'll see. आज तो यार इतना जुकाम हो गया. Okay, now understand, if this is uh, speed and this is time, I mean VT graph. Suppose the graph is like this. So this kind of graph is not possible, because this graph is saying that without consuming any time, suddenly your speed is increasing, and it is no, it is not possible. Whenever any phenomena is happening in the universe, it will consume some time, correct? But in this graph, there is no time taken, so this graph is not possible physically. Next, if I talk about this kind of graph, so suppose I am drawing these two graphs I am drawing. So this is your VT graph. So this is your suppose first graph, the second graph. What are the informations you can collect from the first graph? So first information, when time was 0, your velocity was 0, because it is starting from the origin. Your speed was 0. But in the second graph, when time was 0, you had some speed, whatever, suppose 2 meter per second. This is speed. So this is the first information you are getting. And suppose this is also making same angle, this is also making same angle, theta theta. So, and one more thing, you can clearly see at every different time, your speed is changing. You can see the first graph, you notice your speed is changing, correct? Only first graph you notice, only first graph, your speed is increasing when time is increasing. Speed is increasing when time is increasing. What does it mean? One thing is clear, motion is there or not? Yes, motion is there. It is uniform or non-uniform? It is non-uniform. Okay, why? Because speed is increasing. So you have acceleration. So how will you calculate acceleration? There are if you want to calculate acceleration, there are two ways. Either you find out this concept, v2 minus v1 by t2 minus t1. So data should be given, or you find out with help of theta. Again, data should be given. It means what? Acceleration is nothing but slope of VT graph. You can find out acceleration. But if you want to find out distance, again, in this diagram, if you want to find out distance from t is equal to 0 time to some t is equal to 8 seconds, suppose this is 8 seconds, then this total area you have to calculate. How? Area of triangle, correct? You can find out distance, and I have already solved that. So this question you guys solve and comment. This is speed and this is time. So suppose this is 0 0 origin point, and this is 1 second, 2 second and 3 second. This is 3 second, and this is 1 2 3. It is keep on going. So 1 2 3. Speed is given in meter. So you tell me how much acceleration, and you tell me how much distance traveled in first 2 second. Okay, so listen, how much acceleration, this part I am explaining now, and distance traveled you will answer in the comment box. I know only few students are very serious and watching videos regularly. Because of view I can guess. So let's do this part. I will choose different color for acceleration. Okay, let's take this color. This color is also fine. This color. So at this point, what is the slope? At this point, what is the slope? Theta, theta, they are same, but actually theta is not given. So if theta is not given, then tan theta concept you cannot apply. Then which concept you can apply? You can apply v2 minus v1, that concept. Okay, so acceleration is equal to v2 minus v1 by t2 minus t1. Remember, for acceleration also you will use same formula, and for retardation also you will use same formula. Automatically answer will come negative if there is retardation. Okay, consider this coordinate as t1 v1, this coordinate as t2 v2. So what is time value here? 1. What is velocity value here? 1. What is time value here? 2. What is velocity value here? 2. Okay, so your acceleration will be like v2 is 2, v1 is 1, t2 is 2, t1 is 1. So it is like 1 by 1. So you can see your speed was in meter per second and your time was in second. It means what? Meter per second whole divided by second. You put by 1. So meter per second into 1 by second. It gives you meter per second square. That's why always acceleration unit will come as meter per second square. Correct? So this is the way to calculate acceleration. Now you comment what will be your distance traveled. Comment, pause the video and comment. Now next part, see. Next question. I want to compare. This is graph 1 and this is graph 2. This is your speed time graph. Suppose I have a vehicle A. Vehicle A is following this graph 1. I have any vehicle B. Vehicle B is following graph 2. I want to ask which vehicle is faster. So no doubt vehicle B is faster. Why? Because vehicle B at 1 second, suppose time 1 second. So vehicle A had only this much speed, but vehicle B has this speed, more speed. At time 2 second, vehicle A has this speed, but vehicle B has more speed. So every second vehicle B speed is increasing more faster. So of course vehicle B will cover more distance, right? So vehicle B will cover more distance, and with the help of area also you can check. Vehicle A is covering only this much area, but vehicle B is covering this much area in same time. So of course speed is same, that's why distance covered is of course speed is not same, that's why distance cover will not be same, right? I hope it's clear. This graph is faster, slope of this graph is more, right? Second graph. I hope totally clear. So now what are the standard lines for ST graph and VT graph? You should know this line, this line, this line, this line. These are the standard lines. If line is passing like this, if line is passing like this, if line is passing from origin, these kind of standard curves you should know for ST also and for VT also. So you do one thing, for every curve, like this is passing through origin, for every curve you understand ST graph and VT graph by yourself, ST graph and VT graph, and you check whether you are able to understand the physical feel of all the graphs or not. Okay, now we have some important graphs like these type of graphs. So for VT also I will discuss these type of graphs. So these type of graphs I will take, these kind of type of graphs I will take in next class for speed time graph. Speed time graph is special type. Okay, in next video.